Hey, mathematicians. Hi, mathematicians. This is Mrs. Shopper coming to you with 462 parallelograms. So make sure you're taking good notes with this. You've got some note cards. When you're finished with this, you're going to work on your assignment. So thanks for being flexible and taking to the Ed Puzzle today. All right. So the first thing we're going to be talking about are properties of parallelograms. You've always known parallelograms to mean that opposite sides are congruent, right? Opposite sides are parallel. Well, we also know that in a parallelogram, in addition to opposite sides being congruent, I'm going to switch back to yellow, we also know that the opposite angles are congruent. All right, so if a quadrilateral is a parallelogram, then its opposite angles are congruent. If a quadrilateral is a parallelogram, we also know that consecutive angles are supplementary, and that means that they have a sum of 180. And we also know that if a parallelogram has one right angle, then it has 4 right angles. So I'm going to give you some time. I want you to pause the video and make sure you get this information put down. These are all parts that are going to be true to parallelograms. Okay, so we're going to utilize those here to talk about finding different measurements. So if we want to find the measure of AB, we know that AB and CD are congruent. So the measure of AB is equal to 30. Okay, ABCD is a parallelogram. All right, we want to find the measurement of C. We know that opposite angles are congruent, so we can say that the measurement of angle C is 36 degrees. Okay. In a parallelogram, we also know a couple things about the diagonals. First of all, the diagonals bisect each other. We also know that if it's a parallelogram, that the diagonal separates the parallelogram into 2 congruent triangles. And that's really important when we talk about proving triangles congruent. Okay, so take some time to write that down. I'm going to move on to the next example. All right, so here we have a parallelogram and we want to find some values. Okay, so we want to find R. So in this parallelogram, here's R. We know that WX and ZY are the exact same length. They're congruent. So we're going to set up the equation that 4R equals 18. Divide both sides by 4. R equals 4.5. All right, we want to find the value of S. Okay, so we know in a parallelogram that the diagonals bisect each other. So therefore, 8S is congruent to 7S minus 3. And so that helps us set up our equation. So 8S is equal to 7S plus 3. I'm going to solve that equation out and get that S equals 3. Okay. Diagonals bisect each other, which also means that this is the midpoint. So be thinking about, man, if I had a parallelogram on a coordinate plane, can I find the intersections of the diagonals? Absolutely you can. Why? Because it's the midpoint of the diagonal. Pulling that algebra back again with midpoint, right? All right, in parallelogram WXYZ, find the value of T. Okay, so we have a parallelogram. We know that WX and ZY are parallel. So we have a diagonal. All right, and so we can use alternate interior angles. So we can say that 2T is congruent to 18 because XWY is congruent to ZYW because they're alternate interior angles. See, that's coming back from earlier in the year. So I can set up my equation 2T equals 18, so T equals 9. All right, looking at the next one. Here we go. What are the coordinates of the intersection of the diagonals? Look at that. Set that up. Okay, so the first thing we're going to do is sketch out all of these points. So -3, 0. We've got -1, 3. We've got 5, 4. And we have 3, 1. 1 right here. Okay, we want to find where those diagonals intersect. So we just talked about how diagonals bisect each other, which means they intersect at the midpoint. So this is M, this is N, P, and R. So I want to find the midpoint of NR To find the midpoint, I add my x's and divide by 2, and I add my y's and divide by 2. So -1 plus 3 divided by 2 will get me my x value. And then 3 plus 1 divided by 2 will get me my y value. So the intersection point is going to be 1, 2. It's going to be 1, 2. Okay, 1, 2. All right. What are the coordinates of the diagonal of the intersection? So pause the video, see if you can figure it out on your own, and then come back and see how we're doing on this. So I'm going to go ahead and plot these out. 0, -3, -2, 1, 1, 5, and 3 and 1. Okay, so we're going to sketch this out. I want to find the midpoint. So here is L, here is M, here is N, here is O. So I want to find the midpoint of OM, or I could do LN. Either one doesn't matter. Let's do LN. So I'm going to take 0 plus 1 divided by 2. That's my x value. -3 plus 5 divided by 2. That's my y value. So I have 1/2. 1 is going to be the midpoint. Okay? That's where the diagonals are going to intersect. And you can always check your work by finding the midpoint of the other one as well. Never can you say looks like. Like, I don't want to see you drawing it on the graph and be like, hey, it looks like this, right? That's not what we're going to do. You have to do it algebraically. All right? So now you have time to work on your assignment. Make sure you score it and submit it before class period is over. Have a great day. I'll catch you all on Thursday. Take care.